CBM is a new and advantage maintenance strategy in Europe. Typically, locomotives are inspected at fixed intervals that don't take into consideration the actual condition of components. This can cause either unnecessary replacements or disruption of operations in case of unexpected failures. Condition-based maintenance considers the actual condition of components, as locomotives are continuously monitored and maintenance is only carried out when necessary. Developing and monitoring a specific component is called use case, and so far, more than 40 use cases have been developed. The backbone for CBM is the developed IT architecture that starts with the locomotive's onboard telematics. It sends its data to the data lake, where all data from locos and other possible sources is stored, validated, and eventually forwarded to the analytics platform, where the sense-making takes place. Dashboards are a user-friendly output of the data analytics. To improve CBM actions, the feedback loop allows to gather additional information from workshops. The digitalization and modularization of maintenance rulebooks facilitates the daily workshop processes, and data from the feedback loop and dashboard information can be linked to the superior ERP system. The development of use cases and dashboards followed a design thinking approach to ensure the user acceptance. The process starts with the fleet management as users and their needs and ideas. Their knowledge as technical experts is combined with analytical input from data scientists in form of a hybrid approach. Results of this process are deployed eventually in form of dashboards or more advanced and improved CBM methods such as email notifications or ERP ticketing. These improvements are the consequence of the validation of these results, and thus the circle closes and allows further development. In this video, we will show you different dashboards that give a comprehensible overview of the whole fleet, a single loco, or specific components. The fleet overview allows the user to keep track of the fleet status with the pie chart in the center. It represents the fleet status in the 6 criticality-based conditions, reaching from loco off no data to alarm. Hovering over the pies displays the exact percentage of locomotives, and clicking on it shows even more information on locomotives and components. The aggregated overview of all monitored components in the fleet can be filtered by time spans or conditions. The loco overview shows the condition history of all components. It is visible which components were and which ones are in a critical condition, and shows the impact of maintenance actions, like in this case where the pantograph of loco 12 switches from alarm to OK. Hovering shows more details, and together with the filter options, it improves the usability of the dashboard. Component-specific dashboards, such as this one for the diesel particle filters, have similar usability features. Hovering shows the exact value of the calculated KPI for the filter. According to the displayed thresholds, the bars are color-coded red for alarm, yellow for warning, and green for OK. Clicking on a bar opens a detailed chart with maximum and 30-day median pressure for the last 3 months. It allows to understand the evolution of values and to identify trends. To conclude, condition-based maintenance helps increase the availability of assets. Maintenance costs can be reduced and material can be saved as unnecessary maintenance stops are avoided. Additionally, CBM helps speed up maintenance work as necessary components can be ordered in advance. Dashboards foster the CBM approach because they are easy to use for the fleet management. The developed backend allows for flexible customization of dashboards for specific use cases. Part of the backend is the underlying data structure. This structure can be adapted and implemented in other fleets as well, and can help promote condition-based maintenance all over Europe.